Good afternoon, guys. Quick introduction. You might all be wondering what a guy from Cisco Systems is doing at an automotive conference. The business unit that I work for is a new push by Cisco to enter the automotive industry. Not that we've not been in the automotive industry. We've sold for decades into the data centers and the IT infrastructure of OEMs and the automotive industry. But this is our first venture to get into a real vehicle. So we're putting our stuff, our networking gear, into vehicles. And what we're finding is the transition that the industry has made, the rapid pace of moving from legacy networks like CAN and LIN into the Ethernet world, has been such a phenomenal transition. It's like if you look at the networking world, we went from like 10 meg to 100 meg, 1 gig, and now 10 gig and maybe 100 gig now. But within the automotive industry, we're seeing the need straight away for a 40 gig interfaces, 100 gig interfaces, and things like that. And all of this on 2 wires, right? So in our world, we are used to 4 pairs, 8 wires. We have the luxury of doing TXRX on multiple pairs. But here we're seeing that phenomenal push, the big jump from like CAN and LIN and this really low speed interfaces to those very high speed interfaces. You guys must be very familiar with the use cases for all of those, around view monitor for one, LiDARs, and the high speed sensors for autonomous driving. So what we really build is the infrastructure for connecting all of these guys together, right? So that's kind of what we're working on, and we are engaged with multiple OEMs to specify those products, to work with them to understand what is the requirements for the safety, security, and making sure that all of these products are compliant to ASIL and the standards that are typically in the automotive industry, right? So while doing that, one of the key changes, we talked about this, so from moving over from function-based components, right? You have your ECUs, and most of the ECUs are designed to accomplish a function, and they are siloed to that function, meaning that if they have a sensor that is sensing some parameter that can be used in some other function, it's not available to the other ECUs. And with the move into the domain-based or zone-based architecture, which many of the OEMs are driving towards, we're seeing that sharing of information across all of these things. So the key aspect that we identified in terms of the safety and security is when OEMs are purchasing these components from different vendors, the vendors are responsible for the safety of that particular subsystem, and the way they do it is by owning that entire subsystem, right? And this is very, very important when we start talking about the autonomous driving especially. And the more and more we look in the industry, the entire system, including the sensors and the compute, is coming from one vendor, right? And what the OEMs are requesting is to have the ability to have multiple vendors provide these various components, and for good reason, right? There are vendors who are better at providing sensors, and there are vendors who are better at providing compute, and we need to hook them up together. So the key question is, when this happens, who owns the security of the system, right? So an interesting transition is happening from that perspective, in the sense that in the past, when OEMs used to assign a responsibility or assign the liability for the safety of a subsystem to the vendors, it is more and more coming back to the OEMs to own the infrastructure or the platform on which all of these functions are getting built, right? So the liability is kind of coming back onto the OEMs. So that's an interesting transition that we're seeing, especially with the move to Ethernet, right? And moving over to that 2-wire architecture where Ethernet is going to be prevalent all across the vehicle. And I'm sure you guys have heard of the 10BASE-T1 standard that people are working on, especially the BMW guys, and they want to replace even the CAN and LIN networks with the 10BASE-T1 multi-drop Ethernet architecture. And one of the important points that, that I'd like to mention is the end-to-end service-oriented architecture that everybody is driving towards, right? So they want to be able to publish functions that sensors are providing, and the compute modules or other modules to be able to consume those functions. And that kind of drives that question deeper about who owns the liability for all of this stuff. And from our perspective, it's very interesting because sitting right in the middle and connecting all of these folks, what is the impact of one of our devices going down, right? So if a network infrastructure device that's providing high availability between the two compute modules of an autonomous system goes down, so what does it mean? And how can we even think of ASIL from this perspective? And even from a hardware perspective, right? When we're designing the switch infrastructure and the connectivity between these devices, there is a very well-defined specification for what ASIL-D means for a general-purpose microprocessor or a microcontroller unit. But there is no equivalent for a switch. What does it mean for a switch fabric? So these are all the interesting problems that we're trying to define and push the standards in those areas to accommodate all of these things when it comes to the switching infrastructure of the vehicle, right? So a lot of the OEMs have moved over from the individual ECU-based design to either the domain controller or virtualized controller. A lot of the new models, especially the current production lines, are switching over to the domain controller for most of them, and the virtualized central compute for some of the OEMs, right? And the reason for this transition is obviously the flexibility that the OEM is able to achieve in terms of being able to distribute functions across the vehicle, use or reuse the sensors that are providing some parameters in various functions. One of the key things or use cases that is very interesting is obviously insurance, right? And the way as of today, once the OEM sells a vehicle, there is no way for the OEM to make money off of that product once it's been sold to you, other than obviously dealerships and things like that, right? But that aside, there is no way for post-sale monetization of that $40,000, $50,000 product that the OEM sold you. And that's one of the key things that the OEMs are paying a lot of attention to. And the insurance use case is one of the very basic use cases, and it's extremely interesting for the OEMs because today we get those plug-in devices that, whatever, alcohol, breathalyzers, or one of those things that help the insurance company get information on the driver. But what if the OEM could be that broker or that creator of that data on how you actually drive the vehicle? Like, for example, somebody always follows the speed limit. They're very common sense use cases. But because the OEM has the ability to own that data and extract that data, they want to figure out how to monetize it, right? And that is the reason for the push into this kind of architecture. And as we move forward, maybe 10 years from now, we'll see most of the vehicles in that quadrant or that segment, right? And even today, some of the leading OEMs are looking at this kind of a flexible compute network where everything looks like a data center, right? The car literally looks like a data center. If you look at that picture, that's exactly how a data center would be architected. You have a central switch, and you have computes, and you have data flowing in through that entire pipe. And it's very interesting for us because our experience, 20-odd plus years experience in that industry, is all getting miniaturized into a vehicle as we speak, right? So what are the key problems that we see when we're working with the OEMs on delivering these switching platforms to them, right? I'm sure all of you guys have worked with CAN databases at one point in time or the other, and that's pretty much state of the art. CSV files are state of the art in the industry, and it's in fact, I was intrigued when we looked at the process first as to how an update to the network DB goes on, right? There are a bunch of people sitting and plugging in values into the CSV. There are always mistakes, and the design needs to continuously, we need to iterate upon the design. So the change management of the network database became one of the key concerns for us, and that's something that we worked on to create a tool internally where a lot of the things that Jeff mentioned earlier kind of rung a bell when he was talking about the problems related to identifying where the mistake is, right? That becomes one of the key issues for us when stuff doesn't work, when some of the devices are talking to the other devices, but the information is not being exchanged properly. Then we have to come back down into that CSV file, and somebody needs to manually look through that, right? But obviously, that's not going to work for us, because as we move into safety critical system, providing the network infrastructure for safety critical system, we have to be able to automate that process and trace that process back to the design phase. So some of the things that we have established is a way to iterate on that network design and create a model-based approach for even generating that database, right? Now, it's not only CAN, but it's a lot of Ethernet frames that are flowing through the network. The sources and the destination, there are so many more parameters in the Ethernet frames that are need to be defined, and it's not just the typical the signal value and the CAN message ID that comes in a database, right? And we realize that the way the industry is progressing and the fact that the OEM is taking responsibility for this network infrastructure within the vehicle, we need to provide ability for the OEM during the design phase to be able to iterate on the network design. Nobody's going to get a network design right the first time, right? There are going to be just plain changes. Yeah, you wanted to add a feature, marketing came in with, hey, we need this extra feature, whatever it is, and we need to add that. And we've seen cases where, for safety reasons, they had to resegment the entire network into a different domain just to make sure that they're compliant with their safety parameters or their safety procedures that they have internally, right? So we have to have that ability to change the network parameters as we go. Now, historically, any networking device in the vehicle has had a fixed design, meaning you write your database out, and that's exactly what it is programmed for, and all of this is hard-coded in the code, and there's no ability to change. So the interesting problem for us to solve was, how do you provide the ability for the OEM to change this in a configuration-based approach while maintaining all of the safety parameters intact, right? So what does it mean from a safety analysis perspective when you're able to change the behavior of the network infrastructure via configuration and even to an extent during runtime? For example, for safety breaches, we do allow our devices allow the capability to be remotely upgraded, or the policy to be remotely upgraded, so we can fix those vulnerabilities, right? So what does it mean from a safety perspective? The analysis of the configuration now becomes something that's very important, right? And the nice thing for us is in many of the problems that I just mentioned, there's very little precedent for us. And it's a pretty much an open playground, and we've been having interesting conversations with the OEMs as well as standards bodies to see how we can make this standard, right? Because at the end of the day, it needs to be standard. We never, Cisco as a company, we don't work when stuff is not standard, right? That's not good for us. So, and one of the other problems that we're also helping solve is the ability to plug holes in the network design that exists today, because there is one master database, and the same master database is used for all vehicles, the low-end vehicles, high-end vehicles, and across your entire model or class of vehicles, right? So what happens is, say you have a sports model, and an entire CAN network or an Ethernet subsegment is missing from the lower-end vehicle, right? But it's still part of the database. Those ports are still open. Those messages are still available for somebody to start, spoofing your network or do whatever security-related hacks that they can, right? So our configuration-based approach allows you to plug all of those interfaces, even handle model-based on a per submodel basis, right? So it's the same approach as we have to solve safety problems in the field, or just design changes as we move forward. Right? So another interesting thing is the security. When we're doing all of this network connectivity, how do we handle the security of the various devices that are talking to each other? So the approach that we take is a whitelist-based approach, wherein every device is allowed to talk to other devices, and those communications are determined a priori, right? So as part of the design, the communications are determined, and there's very little variation for any other Ethernet communication to go through our switches. And the way we do it is we have our combination of access control lists and some of our proprietary technology that we work with our silicon vendors. And what it does is it helps us to model the configuration exactly as, translate the configuration into the operation on the vehicle, right? And I think that was one of the key developments that we did in order to be able to analyze the safety aspects of the system and be able to push it through regulatory requirements, and also the safety processes and the validations that the OEMs perform, right? So on the attack surfaces, some of the things that I want to mention is starting from those very low-end devices right in 2011 to all the externally connected interfaces, right? There have been multitudes of attacks. And the reason for each one of these attacks is open ports, right? If the common theme across all of these attacks is open ports, or the way the messages get across through to the end devices that were actually compromised. And that was one of the key things that we put together as part of the effort to make sure that our networking infrastructure will allow or rather not allow a communication that has not already been modeled, right? So while doing all of this stuff, development and testing-wise, right, what are the complexities that we incurred, or what are the additional things that we needed to do was quite a bit, right? AutoSAR typically provides you system policies. You can configure stuff runtime, and also have model-based variants, and have a configuration, boot-up configuration that the device can read and operate accordingly, right? But in addition, we have to have network policies and also security policies. So some of the challenges in having these policies is right from the point, or right from the decision on where these policies exactly get stored and how these policies are validated upon every boot up, are something that we need to start paying attention to when we are developing the network infrastructure devices, right? Security policies, again, are different for different vehicles, different OEMs, and different deployments for that matter, even regulatory domains and country-wise the policies vary, and we have to be able to address those in a very efficient way. Because at the end of the day, the network infrastructure device is the same. It doesn't matter whether it's going to China or going to India or going to any other part of the world, right? It needs to be driven from the point of view of configurability and the ability to adapt to different environments. That was one of the key things that we were able to do with our system. And while doing all of this stuff, right, some of the interesting things related to the software development and testing capabilities that we had to bring in were, traditionally we have agile processes already within our company. And while working with OEMs, obviously we need to have the V design, otherwise nothing's moving anywhere. So the interesting thing for us was how do we adapt our agile operations with the expectation of the OEM, where it's all V-design basis, and the documentation and 26262 conformance is something that's very important, right? In fact, some of the initial conversations were interesting, where the OEMs were talking about the specifications related to the code in terms of cyclomatic complexity, and dead code should not exist, and typical specifications that are part of the 26262, right? And in our processes, when we start, when we use Agile to start developing our code, there was a lot of this stuff that was always there, right? Because people put in code, and there's dead code all the time, and sometimes there's a couple of loops that are added that exceeds the cyclomatic complexity. But how do we adapt both of these things together was something that was very interesting, in the sense that if we don't refactor the code, we are not able to meet the requirements of the OEM. But if we do refactor the code, then obviously the time to delivery and all of that stuff is getting affected, right? So finding that sweet spot between what to do and what not to do was very important for us to be able to deliver products on time and be able to meet the requirements of the OEM, right? And adapting some of the flows, I think one of the interesting points that Jeff mentioned before was Agile does not tell you, hey, you should not do this or you should not do that. It's about how you adapt existing workflows or Agile recommendations into to meet your needs. And that was something that we were able to do from the point of view of from the point of view of automating a whole bunch of the network parameters, right, or the network traffic. We have an entire lab setup that is able to pump different kinds of traffic based on the same database that is being programmed into the device. So the same database is sent into the network simulation devices, and it's able to simulate the entire traffic that would occur in a vehicle, right? So that was one of the important things that we were able to push through. And this is very similar in the CAN world, like Canoe. If you're using Canoe Canalizer, this is something that's already done. But from a system perspective, from the perspective of the entire vehicle, I think that was something that helped us really improve the quality of what we were doing. And lastly, one of the things that we also explored was what are the different metrics, or what are the things that we're not seeing that can actually contribute to us being able to improve the quality of our code, right? And one of the things that we found was certain things like how many times a piece of or a block of code or a piece of logic changes across its lifetime, across a sprint or across a delivery cycle, was something that was a very good indicator of how the code was being developed. typically indicated to us that there was a big gap in the specification, to either due to understanding from a human perspective or just a gap in the specification, right? That was an interesting point where we were able to not only identify the gaps in the specification, but then go a little bit further down and also look at situations where the quality of the code, the initial quality of the code or the understanding of the developer as such was not there, right? So these were two different metrics that we were able to extract from seeing how many times a piece of logic was being changed and how many times it was being touched by people. Well, I have that over here, the gaps in the specification. And the development of the test in the development of the test infrastructure, one of the things that we did was have our test team go talk to the customer first, even before our development team understands what the specification is. Our test team would get the specification first and read the specification and identify the test plan, right? And understand and work with the customer to finalize the test plan. And after that is when we had our development team even go and look at what needs to be developed. So this was, well, not agile. This was more 2.6.2.6.2 based. But some things that it really, really helped us with was to get rid of any miscommunication or gaps in terms of what the customer wanted and what we were actually implementing, right? So if the test plan was already there, and in some ways you could argue that the developer would develop to the test plan, but that was kind of mitigated by good code review practices and more importantly, peer review. So on that topic, well, before we move there, I can't emphasize more the fact that our automation helped significantly in understanding how features were getting broken, right? Especially because from a networking perspective, we're in the middle of all of these features. There were always times when either the APIs of two different ECUs changed or just the message format changed, and because of that, our security mechanisms would trigger and block the traffic, right? And at the end of the day, from a system test perspective, this wouldn't work. So we were able to, by having the automation, make sure that we're testing the changes of the different ECUs coming in through the network DB changes on a regular basis. We were able to make sure that when our device goes and sits in a system test or in an end-to-end test at the OEM's lab, stuff is working as it expects, as it is expected, right? So before we go here, one of the things that I was talking about earlier was the developers developing to the test plan, right? And the code review practices. Some of the cultural changes that we did was to place more emphasis on the code review process and give more responsibility to the reviewer than the developer from the point of view of a feature, to make sure that whatever code was being developed was up to standards and the features would not get broken, right? This helped me from two perspectives. From the point of view of the team, it gave me a second person who was very familiar with the code, because the emphasis on the code review, the person who was reviewing, automatically became extremely familiar with the code and gave me the other person who was familiar with the feature implementation for free, pretty much. And not only that, when it's almost a human thing, like when you're a developer and you're developing something, there's always the corner case that you miss. Another thing that I always encourage the team and both the development and the test team to look at was to see how we can throw away internal APIs. A lot of times there are internal APIs that are created for ease of operation between 2 parallel feature development streams, and they just stay there for no good reason, right? And one of the processes was to allocate one sprint, or at least a part of a sprint, to just go and do code cleanup. And typically that would be done as soon as the feature was fully tested, regression tested, and passed for delivery. We'd go and do the code cleanup, and sorry, not pass for delivery. We'd do the code cleanup and then pass it for delivery, right? So that was something that I always encouraged the team, and we saw a very good benefit from being able to throw away stuff that was really not required. I do want to mention that we were not bound by some of the limitations that AUTOSAR brings to the table. We were operating outside the AUTOSAR framework, but we had to operate in tandem with AUTOSAR-based devices. So that was definitely some wiggle room for us to be able to work on that. And Jeff's mentioned this before, so I just want to say it again. Security, when you think about it, it does not come out of thin air, right? And it does not come out of testing. It does not come out of just using cryptography or anything like that. A lot of times, or most importantly, the security must be part of every person's development mentality. Every developer needs to think of security even when basic choice of functions, for example, and basic choice of where conditions are checked. And all of these things are something that people make decisions on. So security comes from culture. That was something that we learned through this process. So that's my last slide. Questions, guys? I'm open for questions.
Anna, over here.
Just a quick one.
Yeah.
When you talked about evaluating and using checklists or for your code review process, how did you go about creating the checklist? Is it just something that the reviewer can do by themselves in isolation? Or have you tried more in-depth code review processes where you sit physically in the same room or in a WebEx or whatever, and have like some formal documents signed off that this has been reviewed? Like where on the spectrum have you kind of played around with?
Right. So this was definitely not ad hoc, right? You actually mentioned both ends of the spectrum. One end was sit in a room together and have an informal sign-off and like put a signature on it, whatever it is, right? And the other one was just skim through the code and not worry about it. The important thing was to find the balance between these two things. Yes, you want to put the emphasis on the review, and it was clear to everybody on the team that the reviewer would take equal blame for a bug that came out of that piece of code. So the review process was a little bit more thorough and more rigorous than it would have been. Because at the end of the day, everybody has work and everybody wants to focus on the piece that they're developing, right? So the checklists were not ad hoc. So the important point that we identified was the checklists need to be created a priori. And it has to be like a simple either a web tool. Typically, people have review tools, Jira, whatever it might be. And as part of the tool, there were like checkboxes that you need to go and click off. And sometimes in certain cases, we had hookups into the static analysis tools and external scripts that would actually verify if that was true. Like, for example, what was your a lot of the times, dead code can be identified much better by just looking at it, right? Because you're verifying those functions, you know what the requirement is, and you know what the checks are, and you know if some code is going to be hit or not. So that was one thing. And the review process was also responsible for correlating between static analysis and the manual review, the human review process, right? So that was something that significantly helped. Sometimes there are false positives from the static analysis. So it was verified by manual code review. One of the other things that we did use was also formal analysis, formal methods for code analysis. And that was also running on a regular basis to ensure that the conditions for more critical code was was handled properly.